This is part 2 of section 5.5, the law of sines. So here are the results of the exploration from page 435, and it gives you different ways that A, B, and C are arranged and how they're related to each other to explain the ambiguous case. In some of the parts you will get a triangle, in some you won't, and like in part C you'll get 2 different triangles. Sometimes you won't get a triangle at all, like in number 4. So see if these are the answers you got, and if not, you can text or email me and we can go over where you made a mistake or if you don't understand some of my answers. All right, so let's move on to an example that might have an ambiguous case, and that is page 439, number 19. We are given this information about our triangle. We're given that angle A is 64 degrees and side A is 16 units and side B is 17 units. So before you start doing problems that aren't given a triangle, you really should draw a triangle and look at where these parts are. And it really doesn't matter where you put the letters, because it'll still work out the same way. So we know right now that angle A is 64 degrees. We know that side A, which is across from angle A, is 16. And we know that side B, which is across from angle B, is 17 units. Now if you notice, we have side angle. So this is ambiguous. So we are going to have to check to see if it's possible to have a triangle, and then if it is, will we have 2 triangles? So here's how you go about doing that. Since we're given side B, we can use the law of sines to find angle B. So that's going to be our first step. So step 1 is going to do sine of A over side A equals sine of B over side B. And we can fill everything in that we have. So we have sine of 64 degrees over 16 equals sine of B, which we don't know yet, over 16. And I'm sorry, over 17. Now we're going to solve this for sine B. So we know that sine B is going to be 17 sine 64 over 16, and that's going to be sine B. Now we're going to have to put in our calculator that B is going to be the inverse sine of 17 sine 64 over 16. And you could put it in your calculator just like that. And you're going to get that B is going to equal 73 degrees. Now the question is then, so we do have a B, so we know we have at least one triangle. So we can go back and find the measure of angle C, which is going to be 180 minus our 64 degrees minus our 73 degrees. And we get that angle C is going to equal 43 degrees. Then we can find our side C in the same way. So then side C is going to be, let me move this over a little so I have some room here. Side C is going to be A over sine of A is going to equal C over sine of C. So A is 16 over sine of 64 degrees is going to equal C over the sine of the angle we just found, which is 43 degrees. So C is going to equal 16 sine 43 over sine of 64. And when I put that in the calculator, I get C is 12.14 units. Now the question is, can there be a second triangle? So here's how you check that. What you do is you look at the angle B that you found first, and you say, is it possible to have a second angle? because could this triangle have been opened further or closer together because of those two sides? Because remember, the pivot is here at angle C. So are they open further apart or closer together? That side AB would be longer. So here's what you do to find that out. You take, let's renumber these now. We're going to call this B1, C1. So they're all going to have ones on them. A doesn't change. We have 1A. We definitively know that angle A is 64 degrees and its length is 16 units. So the question is there a second B? So we're going to find B2 by taking, remember from the investigation, that it could be reflected here from unit 4. So it's ambiguous. So we have to see by pi 180 degrees if it still can create another triangle. So am I going to have an angle that's going to fit into another triangle? So B2 is going to be 180 degrees minus the 73 that I already found. So 180 minus 73 is going to equal 107 degrees. So the question is, if along with angle A, that has to be less than 180 degrees to form a second triangle. If it is, then we can go ahead and find the other values for the triangle. So A is 64 degrees. So 64 plus my new angle, which is 107, equals 171, which is less than 180. So now I know the measure of angle C2 is going to be the difference from 180. It's going to be 9 degrees. So now I can use that to find the other side length then. So I need my second sine, C. So I'm going to do that by doing A over sine of angle A equals C2 over sine of angle C2. So that's going to give me 16 over sine of 64 equal to C2 over the sine of 9 degrees. That's our C, 9 degrees. So C2 is going to equal 16 sine 9 over sine of 64. So C2 is going to equal 2.78 units. So we have a triangle that looks like this now. Here's our new triangle. I should put these in the same spot they were before just to make it better. So there's A. Sorry. Let me move this down. I'm not drawing a very nice picture here. So this is now 107 degrees, this is 64, and this is now 9 degrees. And so this side is still 17 because that was given. This is 16, and now our new side is 2.78. So we do have two triangles. Okay, let's finish this lesson by doing a couple of application problems that before seemed much more challenging in our last chapter because we were dealing with right angles all the time. Now we don't have that kind of restriction, so we can use the law of sines. So the first problem, we have this picture, and we're supposed to find the height of the flagpole. So we see the flagpole there, and that's going to be side A. And we have a we have a triangle here where we have 105 degrees, we have 28 degrees, and we want the angle between them. And we also have this length. So we have angle, angle, side. So we can use the law of sines. So here's what we know. We first can find the measure of angle A is going to be 180 minus the 28 degrees near the top of the flagpole. And we're also going to subtract off the angle with the horizontal, which is 105 degrees. So we know angle A is 47 degrees. So from there, we can jump right to the answer because we don't need to solve for the whole triangle, just side A. So we can use our law of sines here. So we can say that C, which would be this side, because it's across from angle C, over sine of C, is going to equal A, which is the flagpole, over sine of A. So C is 16 units, and we're going to take the sine of its angle, which is 28 degrees. We're going to set that equal to A over the sine of the angle we just found, which is 47. So solving for A, we get 16 sine of 47 over sine of 28. So we get that A is equal to 24.93 feet. So we can say that the flagpole is 24.93 feet, or approximately 25 feet tall. Much easier than using right triangles. There's a lot less work involved now. Our final problem is number 45 from page 440, and in this problem we have a ship that's out to sea, and there are two lighthouses. So we have a lighthouse at position A, and you have a lighthouse at position B. It was very common back when shipping was huge on the ocean. As a ship was coming near a coastline, it would find its position based on visible light it saw from two lighthouses, so it could figure out where it was and stay far enough away from the coast. So as I said, our goal is to find the distance from the ship to each lighthouse. So we want side AS and we want side BS. So if we look at what's given, we know how far apart the lighthouses are. That's one side. We have the angle that the ship makes with both lighthouses, and we also know the angle along the coastline with angle B. So we have angle, angle, side, which means we can use the law of sines to solve this problem, which will make it a lot easier than trying to create right triangles. So the first thing we can do is we can get angle A, because angle A is the last angle in that triangle. It looks like a right angle, but you can't make that assumption. So what we're going to do is we're going to find the measure of angle A by taking 180 degrees and subtracting off the two other angles in a triangle that we have, the 33 and the 52 degree angle. So we can see while it's close, angle A is 95 degrees, not 90. So now we can use the law of sines twice to find our two sides. We can find side A and we can find side B. So we're going to do that. Let's start with side A. So to get side A, we're going to take side S divided by sine of S, and that's going to equal A over sine of A. So we know side S is 20 miles, and we know that angle S is 33 degrees. We don't know side A, but we now found that angle A is 95 degrees. So solving this for A, and putting this ratio in our calculator, we're going to get that A is 36.6 miles. And now we can do the same thing with B. So again, we're going to start with using S and side S because they are given and they are accurate. So again, we're going to do S over sine S is going to equal B over sine B. So we know S is 20 miles. Sine of 33 degrees has to be equal to our side B, which we don't know, divided by the sine of our angle B, which is 52 degrees. So solving this for B, we have 20 sine 52 degrees over sine of 33 degrees. And putting that in a calculator, we get that B equals 28.9 miles. So now we know how far the ship is from both lighthouses. And that ends our video on section 5.5, Law of Sines. And again, if you have any questions, you can text or email me.